Good afternoon, everyone, and welcome to the ALCTS Virtual Pre-Conference. We can do it, you can too. Metadata automation for everyone. This is the second of a two-part virtual pre-conference being held this week. I'm Liz Wolcott, your host for today's presentation, Session 2, Automating Legacy Data Cleanup Projects, which includes two presentations. Our first presenter today is Marielle Veve. Marielle is the metadata librarian at the University of North Florida Library since 2013, where she creates, transforms, and consults on metadata for a number of digitized collections, including electronic theses and dissertations. She holds a Master's of Library and Information Science from Louisiana State University in 2002 and a Master's of Science in Instructional Technology from the University of Tennessee in 2012. Prior to her position at the University of North Florida, Marielle served as cataloging and metadata librarian at the University of Tennessee from 2006 to 2013, and catalog librarian for Latin American materials at Tulane University from 2003 to 2006. Our second presenter is Maggie Dixon. Maggie Dixon is the metadata architect for Duke University Libraries, where she provides leadership and support for the creation and maintenance of metadata for digital projects, the Duke Digital Repository, and beyond. Prior to this position, she has worked as a digital projects librarian at the North Carolina Digital Heritage Center, the University of North Carolina at Chapel Hill, and North Carolina State University. Before we begin, there are just a few housekeeping things to keep in mind for today's presentation. Today's webinar does not have interactive chat capabilities. If you wish to comment on today's presentation using Twitter, you may use the hashtag you see here on the screen. We will be monitoring the questions or comments on the Twitter feed. The moderators do prefer that if you have questions for the presenters to please type them into the question box on your screen, and the questions will be collated by myself and my co-chair Anna Nitrar. The speakers will answer them as time permits at the end of each of their presentations. Also, as time permits, we will open up questions for both presenters at the end of this pre-conference session. So please feel free to send in questions throughout the session time. Questions which remain unanswered while we are on the air will be answered offline, and the answers will be sent to all the attendees. Also, this webinar is being recorded, and you will receive an email with links to the recording, the presentation slides, and an evaluation within 2 days. Please take time to fill out the evaluation form since it will be used by the committee to plan future events. With those details out of the way, we'll turn the time over now to Marielle for her presentation entitled Editing Legacy Data for ETDs, Description of a Best Practice Using the MarkEdit plugin tool.
Hi everybody, and welcome to Session 2, Automating Legacy Data Cleanup Projects of the ALCTS Virtual Pre-Conference. We can do it, you can too. Metadata automation for everyone. The first presentation in this session is titled Editing Legacy Metadata for ETDs, Description of a Best Practice Using the MarkEdit plugin tool, presented by me, Marielle Veve from the University of North Florida. And this is me at the right side. So I would like to start this presentation with a brief introduction to what is the MarkEdit plugin tool and what are some of its functions. First, the MarkEdit plugin tool was created around 2008 by Terry Rees, the creator of MarkEdit. It's an open source tool that allows interaction between records in some systems, such as the OCLC Connection database and MarkEdit. Users can export Mark records from the OCLC Live database, send them to the MarkEdit tool for editing, then send records back to OCLC Live database where older records can be overlaid with the new ones to reflect updates. The goals of this webinar are to teach you how to grab a group of ETD records you wish to edit from OCLC, export them in batch to MarkEdit, and perform desired edits in batch. Then import edited records back to OCLC Live database where they can replace the older versions of the records. So the steps we will follow in this webinar include, first, installing the plugin tool in MarkEdit. Second, changing the settings in OCLC Connection, first the exporting settings from single record export to batch record export, then creating a new file to put the records we will edit. Third, searching the ETD records we desire to change in OCLC. Fourth, sending the records from OCLC to MarkEdit using the plugin tool. Fifth, performing the desired edits in MarkEdit to the ETD records. And finally, compiling the records back to Mark format and send them to OCLC where they can overlay the old records. Now, the first step in the process is to install and activate the plugin tool in MarkEdit. To do that, just open MarkEdit in your computer and go to Add-ins, Plugin Manager. Now, a new window will pop up and you will choose OCLC Connection BIB file. Then, download. This action will connect your plugin tool in your computer to your OCLC bibliographic file. A message saying the plugin will be activated the next time MarkEdit restarts will pop up, so you will need to close MarkEdit and open it later for it to get properly installed. Before any ETD records are edited, we first need to go to OCLC Connection and perform two steps. First, we need to change the exporting settings from single record export to batch record export. Then, we need to create a new local file in OCLC where we will put the records we wish to edit with the plugin tool. It's very important to remember at this point that OCLC Connection will keep these settings saved until you go back and change them. So after doing all the necessary edits using the plugin tool, remember to go back and change the OCLC settings to what they were set before using the plugin tool. So to perform the first step of changing the exporting settings from single record export to batch record export, open OCLC Connection and go to Tools, press Options, and then choose the Batch tab. As you can see here, Tools, Option, Batch tab. Now the Batch tab will open a window like the one displayed here. In the Record Actions area, you can see here, under Perform Local Actions in Batch, this area performs local actions in batch. Checkmark the bibliographic record export, then press OK. At this moment, we need to create a new local file in OCLC to put the records that we will edit. For that, go to File, then Local File Manager. Now a screen like this one here pops up displaying the path or files you currently have in your computer, local save file. So this is the only file I have so far in my local save file. In there, I need to create a new file to put my file. So I will press Create File on my right side. After pressing Create File, a new window will pop up displaying the exact location with the path where your computer is currently saving the local files. In there, create a new path to put the new records you wish to edit with the plugin tool. In this example, I call my path ETD Retro, as you can see here. I only have this one so far. I need to create a new one. So I type here a name I can easily identify and distinguish my new file from the other paths. So I decided to use the word ETD Retro and then open. After creating my new path called ETD Retro BIB, I will make sure this new path is checkmarked. To make sure it's checkmarked, just hold your cursor here and double click on it. This way the ETD records you will edit from now on can be sent here and not get mixed with your older files from the other place. Then press close. Now that the plugin tool is installed to MarkEdit in our computer, the exporting settings were changed and a new file in OCLC was created. We can go ahead and proceed to look for all the bibliographic records of ETDs we want to edit. For that, search in OCLC by either author and year, as you can see here at the right side, or by title and year. It doesn't matter, however you wish to search for the records in OCLC. For each record you find, let me read the chat here for a second. Okay, for each record you find, press Action, then Save Record to Local File, or simply press F4. This command will send the records directly to the local file you just created in OCLC. Third, after all desired records have been gathered and sent to the local OCLC save file in your computer, it's time to send records from OCLC to MarkEdit to be batch edited. Excuse me. So before exporting any records from OCLC to MarkEdit, we need to restart MarkEdit in 32-bit mode. This is because the internal ODBC driver that MarkEdit uses to interact with the OCLC Connection database cannot be loaded by a 64-bit system. We know this because a message like the one displayed here at your right side will display if you are using a 64-bit system. So to restart MarkEdit in 32-bit mode, open the MarkEdit main menu, as you can see here. Then under File, press Restart MarkEdit at 32-bit mode, or simply press Ctrl-R. This process of restarting MarkEdit in 32-bit mode will display a black screen behind your MarkEdit main menu, as is seen here. Don't worry about this black screen. Leave it open and completely ignore it. Just don't close it and continue with your work. Now go back to the MarkEdit main menu here and open the MarkEditor tool. In the MarkEditor tool, choose Plugins, then choose OCLC Connection BIP File Reader. Now a new window will pop up like the one at the right side here. So where it says connection file to load, choose the file where you saved all the ETDs you wish to edit. In my case, this file was called ETD Retro. Then press Load File. Load File will display a screen like this one here with the titles of all the records you already saved in the OCLC save file. From this list, select the records you want to edit by check marking them at the left side and then press Edit Records. Now a new window with a mnemonic file will pop up. This file will contain all the MAR records you previously checked. At this moment, perform all the desired edits you wish to perform to the ETD legacy metadata in batch. Now is a good opportunity to add the additional fields used in the new content standard RDA, Resource Description and Access, and delete the ones that follow the obsolete rules in the AACR2 content standards. To add the additional fields using RDA and delete the obsolete ones from ACR2, you can start with a tool in MarkEdit called the RDA Helper, as seen here. This tool is available in the latest 6.2 version of MarkEdit. An example of edits that can be performed to legacy metadata in batch with this tool are, first, adding the new RDA fields 336, 337, and 338, used for content, media, and carrier types. Second, changing the contents of the obsolete 260 publishing field to the current 264 RDA publishing fields. Third, replacing the letter C for copyright and or P for production that were previously used in ACR2 to the enclosed symbols used in RDA. Fourth, adding the delimiter E with the initials RDA to the O40 field in between delimiters B and C. Fifth, deleting the GMD or General Material Designation used in previous ACR2 records. And finally, expand abbreviations. So to integrate these changes to your records using the RDA Helper, simply go to Tools, then click RDA Helper to open it and check mark all the fields you wish to upgrade as is seen here in the screen. Then press OK. This screen displays the changes and upgrades that were integrated to a 1982 ETD record with the RDA Helper. Excuse me. The image to the left displays the 1982 record before the edits were performed to it, while the image to the right displays the record after the changes were performed. As you can see here in the before record, there is no delimiter E with RDA in the O40 field, while it appears in the after record here between delimiters B and C in the after record. The information that appeared in the old 260 field in the before record, this information was transferred to the new 264 fields that are used in RDA compliant records, plus the letter C for copyright in the old record that was used in the 260 field was replaced with the enclosed C symbol used in the, for RDA for copyright. In addition, the RDA fields 336, 337, and 338 for content, media, and carrier types were added to the after record, and abbreviations such as illustration were expanded. Another type of edit that can be performed in batch to ETD legacy metadata with the plugin tool includes adding relationship designators E to the authorized fields 100, 700, and 710. Relationship designators are delimiters that can be used to specify the role of the entity name in the field with the work described. Examples of relationship designators that can be useful for ETDs are author, thesis advisor, and/or degree-granting institution. To add these relationship designators delimiters to legacy records, go to Tools, Edit Subfield Data. In there, under Field Type, the number of the under field, type the number of the field you wish to add a relationship designator to. For example, in the image to the left here, I type 100 under field to add a relationship designator to the author of the thesis. Then under subfield, I type the letter E for meter E, and left the field data I left is in blank, and under replace with I type the term of the relationship designator I wish to use for the thesis author, which is author. In the image at the right side, I type 700 to add a relationship designator to the thesis advisor. Before proceeding, make sure the box Add subfield if not present, this one here, is checkmarked. Then press Replace Text, and this will automatically add the relationship designators E to all the fields you specify in the records. Other edits that can be performed in batch to ETD metadata records include adding additional fields that can be useful to the users, such as 540 rights field or 500 fields for the season of publication of ETDs, like for example fall, spring, summer. Also adding the 502 field for degree granted. Finally, after all desired changes have been performed to the records in the MARC mnemonic file, press Save, name that file, and save it to the local disk C drive in your computer. Then compile it back to regular MARC. To do that, go to Compile, File, into MARC under File, and save it in the .mrc regular MARC format. Don't close the MARC editor yet. Now click on the plugin tool, which is the second symbol in blue and green, as illustrated here, to save the edited data back into the OCLC local save file. Make sure it was pressed as an image that says processing data, as in here, needs to be displayed. At this point, the edited records that pass to OCLC will overlay only the records that were placed in the OCLC save file, but not the records in OCLC Live. So to overlay the records in OCLC Live with the new edited data, you will need to go back to that save file in OCLC, then go to Cataloging, Search, Local Save File, and press OK. Now highlight all the edited records. To highlight records, place your cursor in the bottom record here, and then hold and press the Control key while moving the mouse upwards. Finally, press Action, Replace, and Update Holdings, or simply alternate and F11. If there are many files to upload, the process may take a while, so don't worry if this happens. If the records in OCLC Live were successfully upgraded with your edits, then you will see, as illustrated in this image on top, that the columns Replace and Update Holdings located at the far right side will display 2 Cs for each record. This stands for completed. If, on the other hand, the attempt failed, then OCLC will display 2 Fs, like here, in the 2 columns instead of the C. This means the changes did not pass to the records in OCLC Live, and you will need to repeat the process to be successful. Finally, last but not least, I want to mention that upgrades to the records will be displayed instantly in the OCLC Live bibliographic file. And a quick reminder to go back to the OCLC and change the settings back to what they were before using the plugin tool. This includes changing the export settings from batch record export to single record export, and changing the checkmark back to the path that it was before using the plugin tool. If this is not done, any exports that are performed afterwards will be sent to the wrong place. So a quick reminder to change the export settings back to single record export, go to Tools, Options, Batch tab. Then in the Records Action area, under Perform Local Actions in Batch, uncheck the bibliographic record export. And then press OK. This will save the settings on OCLC. To change the path back to where it was before, go to File, Local File Manager. Then double-click with the path you were sending the records before, this one, which is the default one. In my example, I use the default one, so I just put my cursor here and double-click, and it instantly check marks the old path. Then press Close. And that's the end, people. Thank you for joining this webinar. Do you have any questions?
Thank you for that great presentation, Marielle. We really appreciate that. So if anybody has any questions right now, please go ahead and put them into the question box right now. We do have one that's come in so far. Is there any way to pull down holdings?
What do you mean? Pull down holdings? Where?
Or pull down LBDs.
What do LBD stand for?
let's see here. We'll ask our asker actually clarify what they meant by that.
Mm-hmm.
They said holdings records, local bibliographic records attached.
You mean how to implement those changes to your local holdings in your ILS? Is that?
Oh, and another one of our attendees said they're asking about WMS, not connection. Oh, it is world share. Okay, while they're clarifying that, we actually have a question from Twitter that we'll just go to real quick here. Mm-hmm. Is there any way to retain OCLC's controlled headings in this process, or are the headings no longer controlled?
I think I would like to address these questions afterwards to get a better idea.
Okay.
Okay. If you can type them for me and send them.
Would you like all the questions that way, or just the ones we've already asked?
To get a better idea what they're asking.
Okay. All right, so please continue to type your questions into the box and we will get them to Marielle and she will respond to you. Okay, so we'd like to switch over now. We're going to hear from Maggie Dixon on looking back, moving forward, a large-scale metadata remediation effort.
Okay. Hello, everyone. So I am going to be talking today about a large-scale descriptive metadata, large-scale for us at least, descriptive metadata remediation project that we here at Duke University Libraries have been undergoing since the fall. So before we get started, oh, hang on, there we go. Oh, there's me. This is a picture of me. I had to cut out my beautiful family. But I am the metadata architect here at Duke University Libraries. And to briefly mention my background, my library career has been spent to date in digital project management, and I do a lot of metadata work, but while I'm very comfortable working with developers, I am definitely not a developer. So that's the standpoint that I'm talking from. So, to provide a little bit of background on the metadata landscape at the beginning of this project. Duke University Libraries has been creating digital collections really for as long as libraries have been creating digital collections. So I think we launched our first one in 1995. I realized today that our digital collections have reached the legal drinking age. This is not a very long time in the grand scheme of things, but it's really an eternity for digital collections. And over years, our collections have been created by many different people who have different backgrounds and levels of expertise, using lots of different schemas and standards that were often local and very collection specific. And obviously the technological landscape has advanced mightily during this time as well. We have some really great collections, really rich and valuable resources that are available via the digital collections, but the confusion that has ensued from the variety of descriptive practices over the years has resulted in really suboptimal search and browse capability across collections as well as within collections. It's pretty confusing, and we aren't able to easily share our metadata with outside aggregators either. To highlight this, you can see from the slide that I've only provided rough estimates of both our collection and item counts, and this is due to the fact that our collections are delivered using so many different systems that it is difficult, kind of functionally impossible to nail down exact count. But the bulk of our digital collections, which are the focus of this stage of the remediation project, are currently delivered by a custom Django-based discovery and access application. It's very cool and innovative in many ways. But it was built completely in-house, and it's involved so much customization that it really doesn't scale as well as we need it to. So why we're doing this now? The opportunity to address some of the issues that we have accrued over the years came with Duke's development of a high Fedora repository. It's called the Duke Digital Repository. And we have the opportunity to migrate our collections into this platform. So this move allows us to develop more sustainable practices as well as take advantage of the robust preservation environment. Before we began actually migrating the collections over, though, we realized it would be a good time for us to pause, take stock of our current metadata and practices, and remediate that metadata rather than just, dump it wholesale into the new system, which I'm not even sure it would have been possible. But we didn't want to migrate bad metadata and perpetuate these unsustainable practices. And also, in addition to this migration preparation, this has also been a good time for us to take a comprehensive look at our digital collections metadata because of the creation of my position. So I started this position as metadata architect in September of last year. And prior to this time, there had not really been a staff person who had dedicated responsibility toward metadata management here. So, in addition to just cleaning up the existing metadata, we also now have the woman power to use this process to organize and define and document our practices going forward. So we knew that the remediation of our digital collections metadata was going to be an involved and complex process. So we formed a time-limited metadata task group to guide the process. Our makeup consists of myself, I am the chair, the archivist for metadata and encoding from Special Collections who does a lot with the EAD finding aids, a cataloger from Technical Services, our assessment librarian, the Digital Collections Program Manager, and a Digital Collections Developer. We were really careful about constituting this membership. We didn't want it to be so large that we suffered from bloat and couldn't actually get things done. But we did feel that it was important for us to have broad representation from the libraries, and so far so good. It's been very successful. We don't actually look anything like the picture on the slide. So we were charged with a number of tasks listed here, but the bulk of our responsibility is listed in numbers 1 and 2 there. So to do the analysis and review necessary to remediate existing digital collections metadata and to guide the process for implementing recommendations developed during the review process. Before we began this work, we developed a set of guiding principles. So these are on the slide here. The first one, fitness for purpose. Recommendations for legacy metadata remediation, as well as recommendations for the formation of guidelines when creating new metadata for Duke resources, should be developed keeping the concept of fitness for purpose in mind. So as applied to metadata work, fitness for purpose entails that metadata should be appropriate for user and system needs, both now and as much as we could predetermine it in the future. And this was an overarching principle that we used to inform subsequent guiding principles. Broad applicability. Although we were scoped largely to deal with descriptive metadata in the context of digital collections, we wanted our recommendations and guidelines to be developed such that they could accommodate other types of resources and metadata produced by Duke or other campus entities. The Duke Digital Repository is a diverse environment of materials, and so we wanted to make sure that all of our metadata could talk. And so we also wanted to be broadly shareable. With the formation of metadata aggregators such as the Digital Public Library of America, the possibilities for us to share our metadata and thus our resources really broadly is much greater than it has been in the past. And so it's important that our metadata be remediated, created, and mapped to widely used standards in ways that allow for clear and meaningful sharing. And we want to be forward-thinking. So, of course, change is clearly a constant when you're working with metadata and digital resources. So we wanted to develop recommendations and guidelines that allow for this eventuality. Such as adopting standards and practices that have the greatest staying power and allow for the adoption of new technologies. We didn't want to back ourselves into any corners as much as we could. And specifically, we are interested in being aware of linked data technologies and make recommendations that are linked data aware and or ready. So to move on to our data set. The descriptive metadata was being stored in a whole bunch of item level METS records. So one of the developers wrote a script to strip off the XML and reformat the data more like triple statements, which she gave to me in a giant 117 megabyte CSV. That's a comma separated value text file. So that's not, a real big file in terms of digital files, but for just text, that's pretty hefty. It's pretty big. And instead of having one item record per row, I had a single statement about an item in each row. So subject-object predicate format, which you may be familiar with. So there was item identifier, field name, and value. And then we added 3 columns, one containing the name of the collection the item belonged to, one indicating the Dublin core property to which the field map, we do use the Dublin core standard here at Duke, as well as one indicating the collection category, which is an artificial category that I developed, but it corresponds to many of our collections fit into thematic groupings here that correspond to research centers in our Rubenstein Special Collections Library. So here's a screenshot of one item record formatted in this way as it looks loaded into OpenRefine. Having the data in this format was really flexible, and it allowed me to visualize and analyze it in a variety of ways. Since all of the values are atomized, I'm able to use OpenRefine data wrangling software and Tableau Public visualization software to create groupings by field, by Dublin core mapping, and by collection. And I do want to mention, since this was such a very large file, it was necessary for me to allocate more memory to OpenRefine, and there are really good instructions, very clear, for doing this on the OpenRefine wiki for anybody else who's working with large files. So Tableau Public is free visualization software that is really pretty robust. You can create all sorts of interactive visualizations. It's got tons of features that I haven't explored, but for my purposes here, I was able to really easily load my CSV data into the tool without much trouble, and I could use it to create visualizations that were really helpful for the task group's internal understanding of the big picture of our metadata. So this is a screenshot of Tableau's dashboard. So you can choose what dimensions to add to your visualization, and then it's small, but maybe you can see in the upper right corner there are a number of different options for visually rendering your data. And then you publish it to the Tableau Public website, but you can from that point download images. This tool has been especially helpful for me when communicating with our stakeholders. You know, it's one thing to throw a bunch of numbers at someone, but it's way more powerful to do it with a colorful chart. So this is an example. Here is a rendering of our metadata as a bar chart. As I mentioned before, our digital collections tend to come from centers that are part of our special collections library, and a visualization like this is really a pretty effective way to convey which of those centers are most invested in our digital collection development. So we have an advertising research center, the Hartman Center, and clearly they are one of our heavy users. So back to the data. The bulk of the analysis was made possible by loading the data set into OpenRefine, as I mentioned before. And using it, I was able to ascertain that there were 85 unique fields in use across our collections. 24 of these were standard out-of-the-box Dublin core properties, but 61 of them, which we call Duke terms somewhat fondly, are non-standard refinements of Dublin core. So here's another visualization that I created using Tableau of all of the metadata fields in use across our collection. Each bubble represents a unique field. The size of the bubble indicates the frequency of use, and the color of the bubble indicates the field's mapping to Dublin core. So as you can probably see, our metadata application profile is looking a little out of control. There are many tiny bubbles, some of which I'm sure you can't even see because they're just so tiny, and all of this information, all these little bubbles are eventually effectively siloed off from each other and the rest of the world. And this happened because our metadata guidelines were often developed on a collection by collection basis, sort of on a project level, not a programmatic level, and there wasn't anybody to take a comprehensive look at all of the fields in use across the collections when developing these guidelines, and this has resulted in the creation of fields that have identical or very similar application. So using OpenRefine, we further analyzed all of these 85 fields, noting which collections used the field. Was usage consistent within or across collections? What kinds of values were used in the fields? Were they controlled vocabulary fields or free text fields or both? Were they local vocabularies? How many unique values were there? And here is a screenshot showing how I used the facets to analyze the data in OpenRefine. So this is just an example of a subset, and in it I have used the facets to limit by the Dublin core contributor property, and so I'm able to use these facets to see what fields are mapped to contributor, what collections use contributor fields, what the array of values looks like, stuff like that. And then of course I can select other facets to view different subsets of the metadata. It's very flexible and way easier than going through, item by item, which would have been impossible. So to document our analysis, we put all of the fields into a Google spreadsheet, one field per row, clustered by Dublin core mapping, as that conceptually made the most sense. And we chose Google Sheets for this documentation because it worked well for our concurrent collaborative use and allowed for comments on cells so we could record our discussions when we weren't in person as well. And we also really liked the ability to easily and widely share our active document, because transparency is very important for our task group, and we wanted to be able to communicate fully and frequently with stakeholders as much as they wanted to be involved. So here is a screenshot of a chunk of the spreadsheet. As you can see, it's pretty detailed. Also, based on our analysis, we made recommendations for the remediation of fields and values. And we actually documented this in the same spreadsheet, although they're kind of off the screen to the right there. I would have had to shrink it down to where it wouldn't even have been legible to get it into a screenshot. The review and analysis process took about 2 months, but this was really due more to the fact that we met every 2 weeks and had other jobs to do during this time. We probably could have done it faster. We all have a lot of other responsibilities that we take care of at the same time. I did the bulk of the heavy lifting in terms of gathering the analysis data, and the team reviewed it. This was a really useful process for us because it not only helped us to create an action plan for remediating fields and values, but from taking this comprehensive look at all of the metadata, I was able to make informed decisions regarding the development of a set of core fields for a metadata application profile for all of Duke's digital collections, both the ones we're remediating now as well as ones that we create in the future, and that'll help us, going forward so that we don't proliferate tiny bubbles. So in December, we started implementing all of the decisions that we've made. I've been working through the data set mostly on a collection by collection basis, although sometimes I do approach the remediation by category, like those rich advertising collections. It makes sense for them to all be remediated together. And the remediation is ongoing today. I document all of the changes on a field by field level and collection level Google Docs so that we'll have a paper trail, and again, so I can communicate to stakeholders for the digital collections, and also we will of course maintain copies of the original data set as well so that we have some history there. So as I mentioned before, I'm not a developer. I do have the support of developers in my department, but I am really largely responsible for getting this work done, and so I have really relied heavily on OpenRefine for the remodeling and remediating of our metadata. Since OpenRefine has been covered, it's been covered really well in a lot of presentations. I'm not going into a lot of specifics, but briefly, I can accomplish a lot of the work using the faceting feature. Filtering, cluster, and edit is really an excellent way to kind of take a low-hanging fruit approach to remediating the metadata. And regular expression transformations it's nice that that's integrated as well. And of course, there's the ability to reconcile your data against external data sources. We haven't done that yet, but hopefully we will get there soon. For some of the more complex transformations, I found it was easier and faster to use regular expressions in a text editor. I use Text Wrangler. It's free. It's very handy. If you have text wrangling needs, I highly recommend it. And it's much faster working on a large data set than OpenRefine, and it's just better for doing complex regular expressions. It supports grep, which means that basically you can do fancy find and replaces using regular expressions. And in a few cases, like where I've needed to swap out a lot of individual values with other individual values that would have been really time consuming to do one by one, but I couldn't really take care of it using the text editor or OpenRefine, I have had to dip my toes into Ruby scripting. The developer on our task group has been extremely helpful and kind in advising me in this, and I've done a fair amount of self-education on Ruby using Duke's access to lynda.com courses, so maybe some of your institutions have that access as well. I found them to be pretty, especially for beginners. And I want to make a special shout out to RailsBridge, which is an organization dedicated to making tech more diverse by teaching free workshops on Rails and Ruby. I think they do HTML as well for underrepresented groups of people in tech. As I'm a woman, I am one of these underrepresented groups of people in tech, and so I was able to attend a full-day Ruby on Rails workshop organized by RailsBridge Triangle here in Raleigh, North Carolina. And I found it to be a really approachable and informative experience, and I would encourage interested participants to look for opportunities in your local areas as well. They were really friendly and enthusiastic about teaching people of all levels. Look for it. So you might be wondering what the remediation actually consists of. Well, a whole lot of field normalization. We've been merging, renaming, and in some cases remapping fields to more appropriate Dublin core properties. We have aligned our usage with that of the DPLA's metadata application profile, both because it makes our metadata so much more easily shareable with them and others, but also because we think it's a pretty smart model. A lot of good KEDs came together to develop that, and so you know, we want to leverage the work that's already been done. And along with that, we have been consistently applying the core metadata fields that we identified during the analysis process. We've also done a fair amount of value remediation. So the values have been cleaned up and converted to appropriate controlled vocabularies and thesauri. Namely, we're using the Library of Congress subject headings, the Library of Congress name authority file, art and architecture thesaurus for format headings, and the DCMI type vocabulary for types. We definitely have not been able to clean all of the values. If you remember, there were more than 2 million statements in the original data set, and a lot of it is very messy. So we focused on the normalization of geographic terms, dates, and format and type values, as we felt that this effort would get us the greatest functionality. So I do want to highlight one part of the remediation process that I think has been particularly transformative for our digital collections is our implementation of the extended date time format standard. Dates across our metadata set were described in pretty much every way possible, and sometimes machine readable, sometimes human readable, sometimes not. We knew we wanted to be storing data type information in order to facilitate date faceting and browsing and searching. That's like, you know, one of the ways that users really like to interact with our digital collections. And we knew that the current state of the information made this impossible. But there was a lot of information that was included in our dates that was lost if we were to transform it just to sort of vanilla ISO 8601 date time format. So we looked to EDTF, the extended date time format is EDTF for short, and it's a Library of Congress extension of ISO 8601, and it allows for the encoding of what I like to call squishy dates. So these are dates that are very, very common when you're working with special collections materials and include things like uncertain and approximate dates, partial dates, seasons, things like that. So using OpenRefine, I generated a list of all of the unique values stored in fields that map to the Dublin core date property in our metadata. There were more than 12,000 of them. And then I worked with the digital projects developer to programmatically identify the main patterns. Then we worked together to develop a mapping for those patterns to EDTF encodings, and then a mapping from the EDTF encodings to a human readable display format for translations of those encodings in the user interface. So here is a table of a few examples of what kinds of dates that we needed to accommodate. So the existing date value there on the left, in the middle is the EDTF encoded date, and then on the right is the display format that we decided upon. So I transformed the date values in our metadata using the fancy find and replace that I was talking about with Text Wrangler. And then that took care of the great bulk of our dates. Since we'd done all that work to identify the patterns, it made it a lot easier to use regular expressions to transform them. There was some hand editing that was required, although it really was like a couple hours, you know, which for 12,000 different unique instances of dates isn't so bad. And then the developer on our team wrote a Ruby gem for the display format of the EDTF. It's called EDTF humanizes the EDTF encodings, and it is available on GitHub and rubygems.org if anyone is interested. He did want me to, of course, say that it is in beta, but it works. It's great. Another aspect of the work that I want to highlight is our synchronization with EAD finding aids. This is not remediation per se, but I think it's an important part of automating things for going forward. All of the digital collections that we are remediating have corresponding physical collections that are described with EAD finding aids, and these finding aids are managed using archive space. So we wanted to leverage the existing description found in these finding aids without having to store duplicate information in the repository that could, get out of sync easily. So we developed a few different techniques. We store the EAD ID. This is the unique identifier for the collection from the finding aid. And we store this in each item record in the digital collection in order to dynamically generate source collection information, like pulled dynamically from the finding aids for the digitized materials. Archive space creates unique identifiers for each component in the EAD finding aid. So an example of that would be like a folder, and then we store that identifier for the in the item record in the digital collection in order to dynamically generate a link from the repository, from the digital collection, back to that item's contextual place in the finding aid. So we aren't storing all of that contextual information from the finding aid in the digital collection. We're not replicating the finding aid, but we're making the link so tight that it is easier for people to get back and forth. And then along with this, we also store the unique identifier for the item in the repository, which is its ARC. It's an archival resource key. We store that unique identifier in a component of the finding aid, the digital archival object component. We store that at the item's contextual place in the finding aid. So we've got this great bi-directional linking between the finding aid and the item record in the repository. And so, maintaining the strong relationship means that we don't have to, A, store strings of text that can easily get out of alignment, and B, store duplicate information, which could just be confusing for end users. So, what all this work gets us? Well, our remediated metadata makes for a better, I'm going to call it better, cleaner user experience when searching and browsing within and across our collections, and having a cleaner metadata model makes it easier for the librarians and other staff who are creating metadata to implement our metadata application profile. We now have a meaningful cross-collection searching and faceting capability, as each collection isn't using a unique metadata profile. We have data that allows us to develop date and geographic visualization features that we're really excited about. I think that'll be a fun thing for us to do, and we're better positioned for a transition to linked data. So having normalized values that come from defined vocabularies means that when we do decide to reconcile our data against the linked open data sets and store URIs instead, we're much more likely to be coming up with substantial real matches. And of course our metadata is much more shareable now, as I mentioned before, both for sharing with the DPLA as well as any other aggregators that come along. And this last bullet point might seem a little depressing, but of course we're someday going to have to migrate again. This is an iterative process, but hopefully doing all of this work to build clear processes and guidelines, hopefully this will make it easier to do so in the future. And of course, we still have some substantial next steps and challenges. As I mentioned, we weren't able to completely remediate our metadata, so a lot more cleanup needs to be done, especially in creator, contributor, and subject fields. And that goes along with that we want to reconcile our remediated metadata against linked data sources once we get to where we want to store the URIs, but we kind of need the cleaner metadata in order to be able to fully leverage the power of linked data. In the short term, so for this year, I'm hoping to develop a programmatic approach for auditing metadata quality in the repository, so we can make sure those core fields are being applied consistently. And then we also have a broad goal of integrating our digital collections metadata practices more tightly with other descriptive practices here. So, like with the traditional MARC cataloging, this will help us with the transition to linked data in the future as well, so that, materials that are in our special collections that are related to materials in our catalog can talk to each other. So that brings me to the end of my talk. Thank you so much for listening. I think we're going to take questions now, so I guess I'll turn it back to Liz.
Yes, thank you, Maggie. That was a really great presentation. I learned a lot, so appreciate that. If anybody has any questions, we'd ask you to please type them in the question box right now. We have a couple have come in so far, so we'd like to let you all continue to do that while we're asking these questions. Okay, the first one we have is, for undated, does UUUU play well in shared repositories, and were archivists okay with it?
So I actually don't know the answer to that. We chose UUUU in order to be able to accommodate the need for the archivist's need to be able to have something be stated as undated. And as we were locking the date field down to that kind of information, we didn't want to store the string undated, and that had also, there were so many different iterations of that kind of information in our metadata that we wanted to have one standard uniform way to record it. So I don't know what will happen with that. There is a pretty active listserv for the EDTF standard, which it's still in development too, and that was pitched as by some other people on the listserv as a way to accommodate undated, and so I latched onto it. We'll see.
Excellent. Okay, how do you upload the changed metadata back into the repository?
So we have a it's kind of been in transition. Although what I think we're going to do now is we just have a tab delimited text file that then it gets loaded back in by collection. So on a collection by collection basis, I can load it into the repository myself through, there's an interface for the Duke Digital repository for that in the administrative interface. And then if things get more complex with structural metadata, then the developers have to help me with that. But we're hoping to build the functionality to be able to do that in a more complex way.
Excellent. Okay, our next question is, why did you decide to stay with Dublin Core?
Oh, that's a really good question, and I was going to talk about that, but kind of just didn't. I don't know that we have decided to stay with Dublin Core. I think we decided to stay with Dublin Core. Okay, we decided to stay with Dublin Core for this remediation project because there was this sense that we just needed to get the collections migrated into the new repository, and we the time and effort that it would take to crosswalk all of the metadata that's sort of kind of Dublin Core into something else would have made it a more complicated process. Although sometimes I do kind of think like, oh, we might have made it more complicated. It would have been better to me. I would be interested in something that can capture a little bit more nuance like mods. But yeah, that's where we're at. But it is on the horizon. I think we probably will be talking about that more soon.
I think that's a question everybody's asking.
Yeah.
And how did you get the ARCs, next question is, how did you get the ARCs into the DAO tags in archive space?
I actually don't do that. So the archivist for metadata encoding who is on our task group, he does that. And I don't know, but if you want to, if I can get like contact information or, if you want to, I'd be happy to ask him, and I'm sure he'd be happy to share his process for that. Because I know that it, getting it retroactively back into these finding aids it was a process, but he did develop something to do that.
And our next question was the role of the assessment librarian that you mentioned in the team, team at the beginning of it. What is their role?
So far we really have not done much assessment. I think the idea she has kind of a personal interest in metadata and is super smart, so I kind of wanted to have her on the task group. I don't know if that's the best reason for having someone on a task group, but I think we will want to do some some usability testing, and she would be the person that we coordinate with. There's stuff like, I don't know if other people struggle with format and genre terms, but there are things like that where we've made decisions and maybe they're not the best ones, and so there are things that we would like to get some user feedback on, and so she will help us with that when we get there.
Interesting. Okay, our next question is there any way to make your core repository metadata profile available?
Yeah, I think once I get it cleaned up, right now it's sort of existing in kind of a messy spreadsheet, but I think what I would be happy to share, again, if people want to, it's not sort of out on the interwebs now, but I'd be happy to share what we've come up with. It really looks pretty much like the DPLA's metadata application profile. But we hope to get that documented, and then I would like to see some more sort of programmatic services attached to the Duke Digital Repository. We're really in the nascent stages of that kind of thing where that kind of information is freely available to anyone who is interested.
And along those lines, we had, let's see here, a question about, so you have one single application profile for all your collections, and were there any other collections that had to be adjusted greatly to fit a standard profile?
Yeah, so we have one core set of fields, but then there's a shared set of core fields that all collections are using, but then there are fields that are unique to particular collection sets, like the advertising collections. And I'm working on, we have a bunch of music-oriented collections, like sheet music, things like that, and those will have some more specialized needs as well. So we are accommodating for that. I want to be real stingy about adding to the metadata application profile, because at some point it sort of loses meaning if you're just adding to it willy-nilly. I don't know.
Let's see here. Our next question was, how difficult was it to transform Met's XML metadata into the CSV with triple statements?
So I don't actually know how he did that. It's all locked up in a Python library that I really don't know much about. And like I can handle XSLT. Like if I just had a whole bunch of Mets files, I think I could have. Well, I don't know. I'm not sure. I imagine it involved a bunch of XSLT to do it. And it was iterative, that we had to go through it a couple of times because there was a lot of customization that was going on with all of these different collections, and so it's been a real process to unearth all of the layers of metadata from the years that were stuck in various attributes of the METS files and different fields. So it's been an iterative process, tweaking XSLT.
Okay. And did you extract EXIF data from your image files, and were you able to map that data into your repository?
We did not. We really haven't done much with technical metadata.
We had a question that was a follow-up to a previous one. It said, you just touched on this, but I wasn't sure. Was structural metadata also included in the process?
It was not. The structural metadata is still in those legacy METS records, and we're still trying to work out the best process for ingesting those relationships into the repository. We have a few different methods for ingesting materials into the repository, and so for things where, and we're also in the middle of a migration from Fedora 3 to Fedora 4, if anyone knows about that. So we're like migrating and migrating and migrating. There's like layers of migration happening, yeah. So a lot of our stuff is kind of up in the air in terms of like how we're going to ultimately get all that done. But yeah, there's a lot of XML that like I come from a kind of XML background. I'm pretty comfortable with METS, but yeah, it's been a learning curve for me to sort of see that transformed into triples.
Oh, sorry, I just lost my place in the question list. So,
No problem.
The next one was, does your library use different fields for LCSH, thesauri terms, and free keywords, and will that affect linked data in the future?
So right now it's all in the subject field. It's all been dumped into a single subject field. I am kind of able to ascertain, like, by collection. Different collections had different processes for assigning subject headings. So sometimes, generally, if the person doing the metadata decided on Library of Congress subject headings, it generally will be that way for an entire collection. And so far we've got it all in the same field, and I don't know what the linked data implications are. My sense is that if you're storing a URI, you're storing a URI, and so it shouldn't matter. But in terms of getting from here to URIs, I don't know.
That's a good question. Okay, our next one is, how did you cope with the cultural or political dimensions or hurt feelings issues of remediating metadata created by various parties in the organization who might be defensive about the metadata standards and vocabularies used for certain collections, different values, and of course many of these parties may no longer be in the organization?
Sure. Well, for the people who aren't here anymore, like, they've kind of lost their voice. Although we try to do it in the spirit of keeping everyone engaged and involved. But that's definitely been a challenge. One of the things that I've done is I have had the task group has held a series of open meetings with stakeholders, or open and closed meetings where we invite people to sit with us and talk about what we're doing. I try to be very transparent about the decisions that I'm making. It has meant that I need to be able to articulate why I have made a decision, which is a really, a good exercise and not always easy to do. That's a large part of why we were so careful to document things, and I make things so shareable, because I do want to, I don't want to get rid of people's functionality, or people get attached to a certain way of doing things, and so, but we have to balance that. It's a balance against, we're putting all of this stuff into a broader ecosystem, and so there are other challenges beyond just a single collection.
So a follow-up to that, you had talked previously about your stakeholders and that you were doing the data visualizations for the benefit. Who were those stakeholders?
They tend to be people who manage the physical collections. So like when I've had, archivists, curators, things like that. So when I've been doing these talks for the organization, I'll use those visualizations to show what things look like. And I think it's just more helpful than sort of throwing numbers at people. It's really helpful for me.
There's a lot of interest in some of the tools you showed, so it'd be great. We have a few more questions. Are you good for talking for a little bit longer? Or?
Sure. About visualization, I think I saw, Liz, I think I saw that there's, like, Alexa's going to do, there's some sort of presentation going to be done on Tableau, like just on Tableau. Is that, maybe it wasn't a webinar. I don't know if you're familiar with it, but people could look for it if they're interested. I think there's a lot to learn there.
Yeah, there's quite a slate of Alex programming, so that would be great. Okay, so our last few questions are, do you save the legacy metadata to refer back to?
Yes. We're not getting rid of it.
Excellent.
I don't know, we haven't worked out how what we would like to do is be able to have sort of a package of documentation and sort of historical information that gets attached to the collections in the repository. So we haven't figured out how we're going to do that yet, but that it would be under the same preservation hood as the collection. That's the goal.
I think that will make everybody feel more comfortable.
Yeah.
A question about how are you approaching rights management for digital collections, like using the rightstatement.org?
That actually is another thing that is that's on my list of to-dos for this year. We, like a lot of institutions, I don't know if people, maybe the DPLA did a series of webinars recently about their rightstatement.org stuff, and the scenario that they depicted is pretty much the same as ours. We've got so many different text strings in our right statement field that just mean lots of different things. are kind of about rights and sometimes not. Like sometimes it's just contact information, and so I'm dumping it all out, and I'm gonna, so right in the process for remediating it, I'm at least standardizing the string, and then we are going to go through a process of trying to like map that stuff to for the cultural heritage kinds of materials to write statement.org terms and store those instead.
Well, excellent. Okay, do you have a system in place for managing controlled vocabulary terms locally?
We don't. I've had to do that essentially manually, and I think we just started talking about, oh gosh, what's it called? There's some really smart people out there that are developing tools for this kind of thing, and we're investigating different tools for integrating that into our system.
So as a follow-up to that, what are the different systems that your library uses, and how do you put the data back?
I'm not sure. I'm not sure I know. I'm not sure I understand that question. So what are the different, like systems as in the repository, or?
I'm assuming that's what that means.
Okay, so the repository is based on the Hydra stack, so it's Fedora with Blacklight and Solar, and currently it's not integrated with any controlled vocabularies, although we're talking about that, like we were just talking about building like a drop-down pick list for the type field, since that is the DCMI type value list. That's an easy one. But then for things like Library of Congress subject headings and building auto suggest and stuff like that, that's going to be more involved. And how do you sort of deal with latency, and sometimes those vocabularies sometimes the Library of Congress servers go down, so like we're going to need to cache those vocabularies, and yeah, a lot of challenges there. Sorry, that was pretty incoherent, and I don't know if I answered the question at all.
Well, if they have any follow-up more questions, we'll ask them to put them in there, and we'll just give you one more question, and then we'll let you go. We've kept you talking for like almost an hour or so. How did you get the data out of OpenRefine and into the visualization, or also into the Google spreadsheet?
Oh, okay. So I think, let's see. Well, I tend to dump it out of, I export it out of OpenRefine as CSV files. And I think I hand-entered all of the field names into the spreadsheet. There were 85, it was a lot, but we were doing a lot of, that was a very sort of row-by-row process there. But in terms of getting the metadata into the visualizations, I just dump it straight out as a CSV and then load that same CSV into Tableau. I haven't had to do anything to it.
And did you take it from Tableau into the Google spreadsheets, or from OpenRefine into the Google spreadsheets?
No.
Okay.
I will say that, like, beware of Excel. I know, like, other people know this, but, like, Excel has been, like, the bane of my existence. Sometimes you just kind of want to see it in Excel, but, like, Excel does all sorts of horrible auto-formatting, and it changes your text encoding and reformats your dates. It doesn't ask you, it just does it.
We've had the date issue here.
Oh, it's terrible.
Yeah. Well, thank you so much for your presentation and for all those questions. And we'd like to just tell everybody, if you have any more questions, please feel free to put them into the chat box, and we'll be sure and get them to our presenters and have them answer more for you.
Great. Thank you.
Thank you very much. Oh. Okay, apologies, 1 second while we... Okay, thank you guys. We'd like to give a big thanks to Marielle and Maggie for providing us with a lot of valuable information about batch editing ETD files, and also providing an overview of remediation practices for legacy metadata. They did a tremendous job. We'd also like to thank our co-sponsors listed here, the Technical Services Workflow Efficiency Interest Group, the Creative Ideas and Technical Services Interest Group, and the Technical Services Managers and Academic Libraries Interest Group for helping us to promote this event. Before we end, I'd like to remind you that there's a there's one in-person ALCTS pre-conference being offered at ALA Annual Conference in Orlando if you're planning to attend. The details and registration for the ALCTS pre-conference can be found on the ALCTS annual web pages shown on the bottom of the slide here. And just a big thank you to all of our attendees. We hope you found today's presentation useful. You will soon receive a short online evaluation form. Please take a few minutes to respond to the questions and return the form to us. Your comments are very valuable and help the ALCTS Program Committee plan new virtual pre-conferences and webinars. I would like to thank Ipin Chengafi of the Continuing Education Committee for providing today's technical support for the webinar. The support she and her colleagues on the Technical Support Subcommittee provide make it possible for us to present these webinars smoothly. I'd also like to thank Megan Doherty from the ALCTS office and members of the ALCTS Program Committee for their help today. We hope you will participate in other ALCTS webinars and continuing education offerings again in the future. Thank you all and have a good afternoon.